So good morning all. So today we can going to see about 8051 addressing modes. So what do you mean by addressing mode? Means the different way of accessing data is called as addressing mode. So here we are going to see about 8 types of addressing mode. First one is immediate addressing mode. Second one is register addressing mode. Third one is direct addressing mode. Fourth one indirect addressing mode. Fifth one absolute addressing mode. Sixth one seventh one long addressing mode, and eighth one indexed addressing mode. So first we can see about the immediate addressing mode. So immediate addressing mode. So see here, so what do you mean by immediate addressing mode? Means before the 8-bit value or a 16-bit value, it will be preceded by the symbol, the hash symbol. So, and the second thing, you have to note that the data will be available as the part of the instruction. Okay, so see here are some of the examples of immediate addressing mode. MOV A,#25. So what do you mean by this? Means the 25 is the 8-bit data. It will be loaded into the accumulator. So similarly, another one example we can see MOV DPTR, #4521. This 4521 is a 16-bit data, and the 16-bit data will be copied to the data pointer. So 16-bit data will be copied to the data pointer. So if it is preceded by the pound symbol, that means hash symbol, means it is called as immediate addressing mode. So now we can see the next one. The second category is register addressing mode. So what do you mean by register addressing mode? Means both the source and the destination operand. So here R0 and is the source operand and A is the destination operand. So both the source and the destination operand will be a register. So it is called as register addressing mode. Okay, so the operation is between two registers. So it is called as register addressing mode. Here we can see some examples. MOV A,R0. So here R0 is a register. The content available in the register R0 is copied to the register A. Similarly, we have given so many examples. Similarly, we can see add A,R5. What do you mean by add A,R5? Means the content of R5 is added with the content of accumulator, and the result will be stored in accumulator. So this is the example for register addressing mode. Now we can see the third one. So the third one is direct addressing mode. So direct addressing mode means it is nothing but the RAM address. So the RAM address, byte address, will be calculating from 30 to 7F. Okay, yeah. So we can take any address, RAM location after 30 and between 7F. Okay, yeah. So 30 to 7F, we can take any value. So for example, MOV R0, 40. See here, this 40 is an internal RAM address. So how will we explain this instruction? Means the content which is available in the memory location, that means RAM location 40H, is copied to the register R0. Okay, so this is the explanation for direct addressing mode. Similarly, we can say some other example. MOV 56H, A. What is mean by this 56H, A? Means the content available in A register, that means accumulator, is copied to the memory location, that means internal RAM location 56H. Okay, so this is about direct addressing mode. So next we can see about indirect addressing mode. So what do you mean by indirect addressing mode? Means the register, here a register will be used as a pointer to the data. Here we can use only two registers, R0 and R1. So the remaining registers R2 to R7 cannot be used. Okay, only R0 and R1 can be used. So before that pointer register, you have to place a symbol at the rate. For example, MOV A, @R0. That means the register R0 will be a pointer. It will point to a location, some other value. In that value we will be considering it as an address. So suppose for example if R0 is equal to 45H means that 45H will be considered as an address, and from the 45H what is the value available in the 45H is copied to the accumulator. Okay, similarly MOV at the rate of R1 comma B. Okay, so we can copy the content of B into the RAM location which is pointed by the register R1. Okay, to the RAM location which is pointed by the register R1. So now we can see the fifth type. So the fifth type is relative addressing mode. So in this relative addressing mode means it will come under the jump categories like short jump and jump, conditional jump, JNZ, JEC, JEZ. Okay, so these are the things which will come under relative addressing mode. So what is the length of the relative addressing mode? That for short jump means minus 128 to plus 127. So it can jump between minus 128 to plus 127 for the short jump. Okay, so long jump means we can access any locations within the 64 kilobytes of location. Okay, so here we can see some example decrement accumulator. So after decrementing we have to check some other condition. So if you are decrementing means the final value will be 0. So you can either check JZ or JNZ. So like that you can check any other instruction. So the next one, so the next instruction is absolute. So the next one is absolute addressing mode. So what do you mean by absolute addressing mode? Means ACALL and AJump. These are the two absolute mode addressing example. So ACALL means absolute call. So the target address is between some the address will be 13-bit location. Okay, 13-bit. Okay, so you can use ACALL and AJump for short distances. So the control will be automatically transferred to the specified location with the ACALL and AJump instruction. Okay, so this is absolute jump. And now the next one is long call. So long call means we can access full location, 64 kilobytes of location we can access. That means long call or long jump. So it is a 3-byte instruction. So it is a 3-byte instruction. We can access anywhere within the 64 kilobytes of location. So now we can see the last type. So the last type is indexed addressing mode. So what do you mean by this indexed addressing mode? Means we have to read the data from the lookup table entries. Lookup table entries, it is nothing but programmable ROM area. So we can take the code from the programmable ROM area. So we are having 4 kilobytes of on-chip ROM. So from that we can fetch the data. Okay, so see here on example MOV A, #08 and see here MOV DPTR, #1F00. So this is the final line is the example MOV C A, at A plus DPTR. This is the example of indexed addressing mode. So what it will happen means the content of accumulator and the content of data pointer will be added together and together to form an address. So from that address you have to copy the code, that means lookup table entries into the accumulator. Okay, so see here MOVC means here C stands for code. Okay, C stands for code. So here we are having only two 16-bit register. One is program counter and another one is data pointer. Either you can use program counter or you can use data pointer. Okay, so instead of DPTR we can use PC also. PC means program counter. So these are the types of addressing mode in 8051. So thank you, and we can see the next topic in another class. Now thank you.